a little bit of a TS2 cabinet troubleshooting class this morning. As you can see, I got a cabinet behind me. I created a couple of pictures. I'm going to try to recreate some failures and should be able to get something out of it. Just seeing if anybody is anybody logging on the phone, otherwise I'll shut that off. Give it a couple minutes here. All right. I actually have notes I'm going to read off of today. We all know I sent out the email. I sent out the email that had the 2 videos on it for TS1 cabinet overview, TS2 cabinet overview. Hopefully you guys had a chance to go look at that. It'll help today make a little bit more sense. If you're not familiar with the components in the TS2 cabinet, today is going to be on the TS2 cabinet. A lot of what you see today is used. It's the same basic concepts in the TS1. How you troubleshoot it is a little bit differently, but the types of flash and the failures that you have will appear the same in both. It's in a TS1, you'll be looking at a conflict monitor, and here you'll be looking at a MMU or a malfunction management unit. We'll give the phone people one more minute. Okay. I'm going to turn it off. Hold on a second. Okay, here we go. Let's get started. Feel free to type in your questions. I got my phone here if you want to text me questions. All right. So I try to create a script so I make sure I don't leave anything out. So when we do troubleshooting, the first thing, we go out to an intersection and we want to see what's going on. So it's all about site observation. What we see kind of points us in a direction on what we're going to do. Basically, one of 2 ways. If you're going out there to do it yourself, you can do this. If you happen to call me on the phone and say, I'm going to an intersection because it's in flash, this is how I'm going to direct you to find out what's going on. So one of the first things I'll tell you is, go to the controller, hit FFF. Again, just anytime you hit FFF in the controller, get you back to that main menu. So then I know where you are in the controller. So then I can direct you accordingly. So you hit FFF, and then I always say go to 111, which is the run status screen, which would be this screen over here, is that lower screen. And then I would say, look in the lower right-hand corner. And basically the lower right-hand corner will give us some type of message. And as I create the faults, then you will better understand what I'm talking about. So it's gonna tell us stop time, cabinet diagnostic flash, something like that. So from that vantage point, I can kind of start going in a different direction. So I'll go back over here, because I'm just gonna talk here for a little bit. So we're gonna look at the MMU display. So if you have newer MMUs or conflict monitors, they have a liquid crystal display. So that screen is going to give you the error message. It'll tell you red fail, conflict flash, and then it'll show you the indications, typically with arrows above the channels. Again, this is where we have to key on channels. When we look at conflict monitors and MMUs, we're keying on the channels, okay? The phases are assigned to these channels. So when we're doing troubleshooting, I'm going to be asking you, what is it? Channel 2, channel 4, channel 6? Where is our problem? The arrows are going to be over that particular channel that it's seeing the failure, the inconsistency of whatever's not going on right. We'll look at the load switches. We'll see if the load switches are flashing. Depending on what the failure is, load switches could be flashing. They could be dark. We could have input. We could have output. So we want to see what the load switches are doing. We'll have you check all the connections. People always kind of laugh at this. In TS2, as I'm going to show you with the SDLC buses, those connectors, they vibrate, they come off. If it's a replacement cabinet, if somebody was in there before you, they hit something with their elbow and it loosened it up and then it finally popped off. It sounds silly, but what's better than going to an intersection, finding a connector that just came off, plugging it back in, and the intersection takes off and run. We take as many easy ones as we can get when we're out troubleshooting. It doesn't always have to be over the top hard for us. Same thing, BIUs plugged in properly, or you hear us use the phrase seated properly. So a BIU, it'll go in the little, and again, I'm just overviewing right now. When you plug those in, they go in a little aluminum chassis. Sometimes those chassis are a little warped, so the BIU plugs in, but it only goes in halfway. So sometimes you gotta have them pop in. So it could be something as simple as, it's not just the harness, it's the BIU isn't seated in properly. Police door switches, we get this one a lot. One of the biggest culprits is your local police enforcement. They don't do this on purpose. They're out there directing traffic. A lot of them have keys. If not the number 2 key to the main door, they have the skeleton key to the police door, because they're going to put it in either flashing operation or they're going to put it in manual control. So that way they can easier control the flow of traffic. When they do this, they basically understand what they're doing. Shift change comes, another police officer comes out because the job went over. Now he comes out, the signals aren't flashed. He doesn't understand what happened throughout the whole day. So when it's time for him to leave, a half hour later, he gets in his truck and goes, and doesn't realize that he had to put the intersection back into signal operation. You come out to troubleshoot, we start going through the process, and I'm like, did you check the police doors? So always open your police door and make sure your switches are in the proper position. Same thing with the internal switches on the inside of the door, which you can basically see right over here. One of the switches I'll cover right now is our controller on, off, and auto switch. A lot of people always ask me, what should I leave this in? If you leave it in auto, when you lose power to the cabinet or it goes to flash, the controller is going to go, you're going to lose power to the controller. So anytime there's a power interruption, the controller is going to go dark. If this is in the on position, the controller is always going to maintain power, so it's always going to stay on. Personal preference, I like to leave it in auto. It's one more protective level. If something goes into flash or something got hit or whatever, it's one less opportunity to blow up the controller. So I always recommend leaving it in auto. If you leave it in on, it's not a big deal. That's just what my preference is. If you're in auto and the police door switch is in flash, obviously the intersection is going to be, the controller is going to be dark. It's not going to run. If you put it into on, then we're going to power up. We'll be able to program it. So people sometimes get confused that where the switch position that they're in and why it's not running. So that's basically the switch. The other ones all kind of just speak for themselves. Circuit breakers, it's like anything else. A lot of you guys, most of you guys are all electricians. You know what a trip circuit breaker looks like. We have our main breaker. We have 2 aux breakers. A lot of you guys tie auxiliary street lighting or Christmas tree lighting or some other kind of lighting is powered out of our cabinets. So there's always the opportunity where something can trip a breaker in there. So when you come in, check out the breakers. They're right there. Sometimes you trip the breaker and that's what causes it to go into flash. You reset the breaker, it trips again. That now points you in the direction that it could be something auxiliary to the cabinet and not going on in the cabinet, depending on what you have tied into it. And then always look at your field signals. You can do that when you're pulling up. Is everything flashing? Do you have signals on while they're flashing? Is only half of the signals flashing? And this could all tie back to our signal bus and what's going on in the cabinet. Are your PED signals dark? Are they flashing? When we're in flashing signals, your PED signal should be dark. If yours are flashing while it's flashing, we're probably getting a backfeed somewhere because that shouldn't be happening. So observation is key when you pull up. The more information that you can tell me over the phone, the quicker we're going to find the root of the problem and you'll better understand what's going on out there. Because in the end, it's just electrical circuitry. It appears a little bit differently, but it works the same as standard electrical circuitry that you guys are all used to doing. So I try to break that down. I consider that level 1. There's like 3 levels that we do this. That's level 1 of troubleshooting, the obvious, just look and see what's going on. Basically, that is all the stuff in the cabinet that you would look for, obviously. One of the key elements is we want to know, is the problem in the cabinet or is the problem in the field? That's a best case scenario if we can identify that quickly, because then it points you right in a direction. And it's always funny because 9 times out of 10, when we identify this problem to be in the field, the person on the other end of the phone always seems to know right where to go to find the problem. I understand he's trying to go through a process of weeding out what it may be or not be. So that's what I try to help you guys on the other end of the phone. So, but I think, it is funny that most times you guys are like, oh, you know what? It's the pedestal on the northwest corner. It's a splice. It's something you've probably had trouble with before, and it just keeps coming back to haunt you. And now this is time where you're actually going to rip it apart and either pull new cable or do something. So that would go along with checking for anything that's knocked down at the intersection. You have a pedestal that got knocked over. Sometimes, like I said, you look at all the signals, you don't realize a PED signal just got whacked off. It got whacked off the top. Something like that. PED button got ripped down. There's new damage due to construction. Nothing was going on last week. There's all construction going on right now. They cut through a conduit. They cut up a loop. Who knows what they cut up? You know what the utility companies are all capable when it comes to our intersections. And then the one last thing is when you open the cabinet, there's always a plethora of unpleasant smells in there, from rodents to gas fumes coming up out of the conduits. But the one we're keying on is that burnt electronic. It's called Lexolite. I forget what it's called. But when a IC chip is burnt, it has that unique smell that we all know oh so well. That means that a component just got burnt up and it has to get replaced. So we want to check for those obvious smells and also the visual cues that we get. Okay, so we got through all that. We didn't really find anything. Everything looked like it's supposed to be. Nothing really smelled or anything. So now we have to move on to level 2. If we find a problem, start corrective action, we know level 2. Troubleshooting is required. When we do level 2, you have to have these tools for us to be able to troubleshoot properly. If you don't have these tools, there's nothing more frustrating is when you guys get all set up and everything, and I'm like, do you have a multimeter? Get your multimeter. I don't have one. Or you have a multimeter with bad batteries. Do you have a soldering iron? You don't have a soldering iron. Some guys don't even have a screwdriver. So be prepared if you're going to troubleshoot the intersection. Most of you guys all have a little tool bag. Keep that tool bag in whatever truck you have, so that way you're prepared for whatever problem that we have to. Because there's nothing worse than when you got to go get a spare part. So I'm going to go with some of the tools. I got them all laying down over here. So, like I said, basic soldering iron, right? A lot of you guys, some people use the propane ones. I recommend a wired one because we can always get it fired up. And if you got a soldering iron, you have to have solder. We often have one without the other. I know it's just a trip to Home Depot way, but it just delays everything. So a soldering iron and some solder. Basically, a couple of different screwdrivers, flat blades and Phillips. It's key to if you also have a smaller one. So this is a little Itera screwdriver.
Now we're gonna strip the back home after lunch.
It comes in both.
Get your laundry in. Going once, going twice.
Why are we getting a little back beat?
Mikey, I got some underwear.
Okay. All right. It also helps to have a pair of crimpers. So if we get a crimp stake guns onto a wire, a pair of pliers, and a pair of strippers. Obviously the stake guns too. So if you have all of those, and of course, a multimeter, that basically will cover all the tools, everything we need to troubleshoot to get us through whatever the problem is. So try to be prepared when you get to the intersection. It just makes the process go quicker. We're already frustrated because we got to go deal with this, and more than likely the weather's bad anyway. So that's basically our tools. Spare equipment. I completely understand the lack of spare equipment that's out there. What I would say on your trucks, these pieces of equipment You can get out of basically every cabinet. We all come across it. Even if you just have a couple of each, you should have this stuff in your truck. And that would be a couple of load switches, a couple of flash transfer relays, a couple of flashers, and a couple of BIUs. These are the components that usually get burnt up the most. These are the most cost effective, the cheapest components that we have. So these are the ones that we should have on our truck, because there's nothing worse. Again, we've all been through it. Yes, we supply a cabinet that has a full complement of load switches. I don't think every manufacturer, every supplier does, but we do. But what happens is you get a bad load switch, you swap it out. Ironically, people put that load switch back in the cabinet. They don't know enough to throw that bad load switch away. If you're one of those guys that want to collect load switches and take the cubes out and try to get one good one out of three, God bless you. I did that when I used to work at the other company back in the 90s. I used to sit around on rainy, slow days in the winter, take load switches apart and try to get one out of three. If you want to do that, that's awesome. I can appreciate the effort, but mark the good load switches and the bad switches, because there's nothing worse than troubleshooting with bad equipment. One of the biggest challenges we have is troubleshooting with bad BIUs. I have people come out, I'm pretty sure it's good, I don't know what's good. We chase our tail for at least a half hour, and then we realize that the BIUs we are troubleshooting with just aren't good. And then the bonus equipment, this is going to be the hard stuff to have. Obviously, if you have a controller, if you have conflict monitors or power supply, that's stuff that you should at least have one of. If you don't have it, go to the powers to be that spend the money, that have the budget in town, and we can give you pricing. And so that way you can at least get some spare equipment on the shelf. As contractors go in and do jobs, the state comes in and does the job. They replace all your old stuff. Don't be shy to ask for that spare equipment. Some agencies don't. The ones that do, I go into their shop and they have a whole ton of spare equipment. So the state has a lot of spare equipment. Use them as a resource if you don't have anything. They're a bunch of nice guys. They like to share, especially if they're locally. So have a relationship with your state guys. Most of them are all on this meeting site right here. We're all in it together. Basically it goes city intersection, and then you have an off ramp that belongs to the state. We're all here to help each other out because we all know what it's like to be out there without spare equipment. Don't take without asking. I'm not saying that. Most people put padlocks on their cabinets now, but if you get jammed up, it's a resource that you guys can use to save you. Instead of driving an hour and a half, maybe you just have to drive 15 minutes, get a BIU, get a load switch, get something back up and running. So that covers the spare equipment. And then the other main thing you do, if you can't do anything else, there's nothing worse than having, actually, this could go two ways, because some agencies would prefer this. If the intersection is dark, typically the first thing we want to do is everybody says, let's get it flashing. So depending on what the damage was to the controller, if we've shorted out the back panel and the flasher isn't working, we have a couple of different. So here's something that's handy to have. It's a little traffic sensor core, 25 dB, 120 volt flash cube. So it's good to have a couple of these on the truck. These are ones that we have in school zone flashers. Basically, you can wire this in to the cabinet, put the signals on it, it'll wig-wag, and you get the intersections to flash that way. So typically, everybody usually feels a little more comfortable if you have a flashing intersection. I understand that there's agencies out there that if the signal isn't running, they'd rather just shut it off. They'll stick four-way stop signs up there. That's how their city likes to handle that. That's the DPW's method to do it. Whatever you're more comfortable with. But the point I'm trying to make is if you can't get it flashing through the flasher on the back panel, have a couple of these little cubes in there. They don't cost a lot of money. You can always grab one out of a. You have some of our school zone signals will have a regular NEMA flasher in there. Other ones just have the little flash cube. These are handy because you don't need a socket and you can just wire it in there and it can sit right on the deck. So again, either the flash cube or the four-way stop signs, whatever works for you guys. Okay, so now we're going to get into the actual a little bit of troubleshooting here. So one thing, so I have, what's gonna have, you gotta bear with me a little bit today. So I've explained this before. This is something we call a telnet session. Basically, I have an Ethernet cable plugged into the controller to my laptop, and I'm able to bring up the punch screen. When I lose power to my controller through the troubleshooting today, the screen is gonna lock up, so I'm gonna have to restart it. So it takes like 30 seconds, so you have to bear with me while we do that. One other thing that we're gonna go over is failed components. Let me go back. All right. So how do we know, with obviously looking how we identifying that our components are failed? In TS2, one of the big things that you have is your transmit and receive lights. So as we're operating, again, I'll demonstrate it over here, you'll see a bunch of transmit and receive lights that is sending the data back and forth to controller, from BIUs to controllers to MMUs over the SDLC assembly, okay? The one thing, if you don't see transmit, a lot of times we'll say, is it transmitting receive? We're basically talking about the LEDs flashing on and off. It's an easy identifier. If that's not happening, then we know something went down in the bus and it's not working. I'll just go down each of the components. So in the control, with the controller, if you go out there, the controller has a dark screen, it has no screen. If the screen is power cycling upon itself, then we know that there is something wrong with the controller. If the controller is powered up and the screen is staying on, then it can still be something wrong with it, but that's usually that's a telltale sign that there's something good with it. Obviously we can burn things up. In TS2, there's a little less going on in the controller because we're doing it over the SDLC bus. Typically the port can get burned out on it, the port 1, and we'll go over port 1 fails. That's gonna be your cause, where if you go back to TS1, where we're using the A, B, and C connector, and we have all going on, those are all hardwired inputs and outputs. So when those burn out, that's when you get the intersection running, and a phase 1 green or a phase 2 yellow seems like it stays on all the time. That means you blew the signal driver in the controller. It's a little IC chip in there in that controller. So it's still running, but it just stays on all the time. So that controller would have to go back for repair. MMU, they're pretty straightforward. Basically, again, dark screen, no screen, if they're cycling power. If the transmit and receive lights are dark, even when you plug them in, and this is assuming that we have these devices turned on in the controller, then the MMU is bad, and that's not working. Hold on there. I should be checking my phone. Let me see. Is Greg Geethan in? Can you see if Greg is trying to get in? There you go. That's cool. Okay. Was there a question up there, or somebody? Did somebody make a comment?
Someone's talking about a previous video.
Oh, okay. So that's the MMU. Like I said, assuming that the MMU is turned on, we should be seeing those transmit and receive lights. So if they're dark, then and I actually have a bad MMU that I'm going to plug in later and show you guys. The power supply. The power supply, we refer to the auxiliary power supply that sits on the shelf. Typically, the older ones is a CPS 102. We now have CPS 105s, or you could have an EDI 250. Basically, they have an array of LEDs on the front of them. A lot of times I'll say, look at the power supply, make sure the LEDs are on. If the LEDs are out, they have fuses in there. It might be as simple as we'll replace the fuse. Sometimes you put the fuse back in, it blows instantly, then we know that there's a short in the power supply. They're pretty durable, but they do go. So that, again, that's something else. That's a bonus piece of spare equipment to have. It's good to have one. They're all interchangeable. You can use them from other manufacturers. They all have the same military style plug on it, but they're good to have. BIUs, bus interface units. These are the units that plug in back and forth into the SDLCs. You have BIU 100s, BIUs 200s. The black EDI ones are BIU 700. They're all interchangeable. For the most part, BIUs are interchangeable with other manufacturers' BIUs, but I will tell you it doesn't work 100% of the time. I don't necessarily think it's the BIU itself. I think it's more the SDLC cable, and I'll explain that to you. We've gone over this before. So in a Siemens cabinet, we have the hub. This is what we call the hub assembly. So this mounts on the side panel. And then we have the BIU cable. Yep. You'll see one end has screws on it right here, and the other end has the clips. The clip end goes on your device, your controller, your MMU, your BIU. That's why we have the clips on there for security. The screw end goes into my hub assembly, which has female slots, so I can screw it in and secure it on there. If you'll notice, I can get it close up here to the camera, you'll see on the device end, it's totally pinned out. On this end, we only have the 8 pins that we're using. In other manufacturers, both ends will look like that. And we feel as though doing it this way gives you a better secure hookup, because it's connecting all the pins inside of the connector on the device. Even if half of them are dummy, but it just seems to make a better secured connection, which allows for better communication through this cable back to other devices. So again, I don't think the BIUs are the problem. I think it's the different kinds of SDLC cables that manufacturers use and how they pin out the devices that breaks down the data communication, which may lead you to say, you know, manufacturer A BIU doesn't work in C's cabinet. I think it's more the cabling, or we use the hub assembly. Other manufacturers just have this as a free wired end, and they just do terminations onto a terminal lock. So that just adds a lot more failure points. Now you're more susceptible to corrosion. That can all break down the data. So that's my take on BIUs and SDLC. A lot of people will just sell these hub assemblies. The hub assembly with 5 cables, and I see them in our older Eagle cabinets before we went to the hub assembly. We had the problem. We had those same problems. That's why we went to the hub assembly. That you'll just see that locked in there, and they just take the other one out. I'll see them other manufacturers' cabinets. So that's my 2 cents. I think we did a really good job on this. So you can use it in any cabinet that you want. All right, so that's the BIUs. So with the BIU, you're going to look at the power light that's on, the transmit receive light, make sure that's all going. If that's not going, then that's going to pinpoint us in a direction. I just covered the SDLC cables. One other thing in the cables is these little pins that are in there. The pins break. They do 2 things. They break and they push back in. So it only goes on one way, but if that pin isn't seated or there's something loose in the connector, sometimes just having that pin pushing halfway will give us the failure that we have. So it's always good to look at them. What I like to do is I'll actually take it and I'll push my finger down on it, so I can, put a ½ pound of pressure, and those pins should all stay. I should see all the pin marks in my finger. If one happens to go down or if one's broken, that's going to give us our problem. And they're easy, like I said, this way they're easy to replace. If you can glom 1 or 2 BIU cables from somewhere out of a cabinet that could destroy it in a knockdown or something, it's good to have a couple of these on the truck as well. So now that I think of that, SDLC cables are definitely beneficial to have. All right, so I think that covers all the spare parts. Okay. All right, so now this is where we're going to, I may lose connection, but I want to go through a process. I went over it a little bit. You're probably saying, Gary, how do I know that I have the bad BIU? So here's a process. I know a lot of you guys that have troubleshot over the phone with Jimmy Decker over the years, and I think Chuck Bluto used to do it this way as well. It's kind of foolproof. It works pretty good. It's not that, it's just a process. If you guys learn how to do this, you'll be able to basically determine whether your BIU is good or bad. So basically, I'm gonna stand up so you might see my back around here a little bit. All right, what's that?
Someone else spotting it.
All right, so when we go to the controller. So our controller's our intersection is in flash, and we're trying to get it going again. One of the processes for finding the BIU is, what I'll tell you is, okay, I want you to go in, turn off all the BIUs, and just leave the controller and the monitor on. So you would go from the main menu, FFF from the main menu, 4 for unit data, 7 for port IO, and you'll see in this where I have it running, I got BIUs 1 and 2, right? I got detector BIU 1. I have my controller unit and my MMU. So I have these guys turned on. So if I'm trying to find a bad BIU, what I would do is leave these 2 on, turn this guy off. My controller is still running because that's just my detector BIU. I don't need that to run the cabinet. But then as soon as I turn these guys off, I'm going to go to flash. Oh, it's going to, hold on. It's going to run. That's weird. All right, so now I'm in flash. It's going to start again. All right. So what I would do is now if I go to okay. So my intersection is in flash right now. My controller is running, but if you can see up here to the left, you'll see where my intersection is actually in flash. So this is my light board that I have. Okay. So now we're going to go. So I go into my reports, and you'll see that I have, let me clear these out. Oops. So I clear my log out. Back where I was for, okay. So I got my BIUs turned off. This is going to break that connection. But let me try putting one of them. I'm trying to minimize breaking the connection that I have here. Okay. So now my log was clear. I'm going to cycle power. It's going to go off. Use my switch to come back on. There's my message. I close this. So let me just go restart this again. Okay. I got my connection back up. I go to reports. I go to alarms. So you'll see I don't have a frame fault for BIU number 1. So because I have BIU number 1 on, if BIU number 1 was bad, it would register a frame fault in there of like 138. It would say 138 fault, basically identifying that this BIU is bad. So because I don't get a frame fault in there, it's just not running because I don't have BIU number 2 on. So now if I go back, so I'm always going to have you clear this log out. Hit clear and enter. So we clear the log out. And we go back in. Now I'm going to turn on BIU. I'm going to break this connection one more time. It's going to come up. It's going to tell me I lost my telnet connection here in a minute. All right, intersection cabinet's back up and running. ADYM, enter. Cable M2, enter. SC, back up. All right, we'll hit our reset. Back up and running. We'll go back to logs or reports. We go to 4. We always hit the up arrow to get the most recent. And you see that I don't have any more frame faults in there identifying a bad BIU. If I had gone through this process and BIU number 2 was bad, when I say BIU number 2, so again, here's what I refer to as BIU number 1, our upper BIU. Our BIU number 2 is our lower BIU. Each of them, when they fail, they give you a specific frame fault, 138, 139, 143. So when I try to restart this, as I'm turning on the BIUs, it's gonna give me a specific frame fault that's addressed to either one of these. The other thing is it's also confirming that my cable is good, that I have a good connection from here back to my hub assembly. So we can do that. So we're kind of killing a couple birds with the same stone. And that's what we're trying to do, because if one of these are bad, especially if it has a ground issue, it's basically gonna have a ground issue or a 24-volt DC issue in it. If one of these are bad, it shuts down this whole bus. So now it makes it seem like I have 3 bad BIUs or 2 bad BIUs, but really I just have 1 or 1 cable. I'm trying to identify or isolate if it's the component or if it's the cable. That didn't really flow as great as I wanted to. I didn't have any bad BIUs. If I had a bad BIU here to plug in there, that would have made a little more sense, because I could have been able to replicate the failure a little better. But just I wanted to expose you to that process, because that's something that we will continue to have you do over the phone when we're troubleshooting TS2 cabinets with BIUs. So it's just so you understand the process of doing it one step at a time, one BIU, then the other BIU, and we kind of go from there. So typically, we've had a lot of success in doing that process. Okay, so we go to there. So now what we'll do is all right, now what I'm going to do now is I'm going to create some of the conflicts that we normally see out in the field. These are kind of the general ones that we see. I'm going to show you just give you an example of the causes. Like I said in my email, that there's a lot of different ways that these can be caused. I'm just kind of going to expose you to a couple of them, so you'll be a little bit familiar and kind of point you in a direction of what these failures would look like. Okay, so the first one that we're going to have is the conflict flash. So basically a conflict flash is generally we have conflicting signals up there. You can have conflicting signals that are not concurrent. So you can have a side street green, a main street green, a side street yellow, and a main street yellow. there's a couple of different ways that this can come about. So the way it would look is I'm going to clear out my log, hit the F, and then we also have the MMU CMU fault. So I'm going to clear that out. Another important thing right here, this is where it's important to make sure that we have the most current date and time. So right now it's 6/2/20, which is accurate for the date. And then the time is 10:43:3, that seems pretty good. So we need to have accurate date and time. So that way, when we go to look at the logs, it matches up to the troubleshooting time period that we know about. Okay, so that's all good. All right, so I'm going to create a conflict. So basically the way I'm going to do it, this is the way so when we build every cabinet, we do a conflict monitor test to make sure that we have all the jumpers right, our compatibilities are right, and it creates the fault, and then we print out a report so that way we have it from somewhat of a liability standpoint to make sure that we do it. For those of you that do final inspections, there's some consultants that actually have you do the conflict monitor test in the street. Obviously, you have a police officer out there because it's going to go in and out of flash. It should be done at every inspection on every turn on of a new signal. Anytime you modify a cabinet, technically this should be done. It doesn't get done enough, but it should be. And technically it should be done once a year, which would validate that your monitor is still working properly. So stuff to keep in mind, not trying to create more work. It's more of a security, safety, and measures type of thing. Okay, so for this instance, I'm going to come over here to my board right now. So it looks like I'm in, let me try to get back to, because I took some pictures, so I want to try to get these to line up. So let me wait till I get to 3 and 7 green, so then the picture will make sense. Again, my controller is just in default. I'm in recall, I'm cycling around. So right now I'm in 2 and 6 green. So when I go to 3 and 7 green, I'll put in a recall. So this is just basically an old manual control cord that we plug in, and when I hit the button, it puts 110 on the tip. So I'll go, so all I did was light up 2 green right there. I applied 120 volts to 2 green. So that's as if I had a green indication on phase 2 green and a green indication on phase 3 green. So if we look at our controller right now, as soon as that happened, we went to stop time. Intersection goes to flash. This happens instantaneously. We can't have 2 conflicting greens up there. So I'm going to stop I come up to the intersection. I see that it's flashing. This is basically this is mimicking my signal flashes out on the street. If I look down on my load switches, you'll notice my load switches are all on. They're on these are input-output load switches. So I have the input side that's lit right now. The input side is the 24-volt DC side. The output side is the 120-volt AC side. So stop time basically means that we stop the controller in the time or the sequence that it's at. So right now, if I look at my load switches, I know it's hard for you to see, but I can look at my load switches and I have a 3 green and a 7 green. So 3 green and 7 green typically on my side street left turns. So they're on together. So basically we had a conflicting movement light up. So now we're going to troubleshoot to find out what that is. So if I come over to my controller, so I'll go into 0 for reports and I'll go to 4 for alarms. Oh, just another thing. On the lower part of the controller screen where it says lockout and then it says stop time -1/2. This is what I referred to as go FFF. So FFF 111. You'll see it gets you to the same screen. In the lower right-hand corner, it's going to give us an error message. So the error message right here is stop time 12. So I'm going to go, so I say, hey, go FFF 111. What does it say in the lower right-hand corner? People sometimes get a little confused. They start telling me min green. They tell me what phases are on. I just want to know what the error message is right there So then that kind of starts the process for me on which way I'm going to send you next. So stop time 1/2 just simply means ring 1, ring 2. That goes back to our ring structure. Ring 1 being phases 1, 2, 3, 4. Ring 2 being phases 5, 6, 7, 8. So we're going to go to 0 for reports and 4 for alarms. So we open up the alarm status. There's nothing in there. So now it's telling me, okay, so it didn't register a problem. So now I'm thinking the controller's not registering the problem. This most likely could be a field problem. It's not a cabinet related problem. Again, we're always trying to identify is the problem in the field or is the problem in the cabinet. So I'll hit the F key once, and then I'll hit the 8 key for MMU CMU faults. Okay, so now this gives me a little bit more information. You'll see at the top it says conflict fault. And it says channels. Again, there's the key channels. So it says 1 through 6, 1 through 8, and then 9 through 16. That's all that we really care about. Don't worry about the other ones. You'll see where it has reds. So whatever channels are supposed to be red. So we have reds on the top. You'll notice that on 1 and 5, we don't have a red, yellow, or green indication. That's because we have flashing yellow arrow going in this cabinet. So channel 1 and channel 5, which are associated to phase 1 and phase, only have a green. So there's no red indication. So that's why there's nothing over there. Again, going by my load switches, I had load switch 3 and load switch 7 was green. So you see the 1 on the bottom line is green and green. But you'll also notice that there's a green under channel 2. There should only be a 1 in each column. There should be 1, 1 in each column. So if you look at all the other columns, there's either a 1 on the green or a 1 on the red. For channel 2, there's a 1 on the red and the green. So that's going to tell me that my problem is in channel 2 green. And I also know that because channel 2 green should not be on with 3 and 7. 3 and 7 are my side street left turns, where channel 2, in this case phase 2, is my main street green. So that's going to tell me right there that, okay, I have a problem with phase 2 green, channel 2 green, that is lit up. That has 110, that has 120 volts on it when it shouldn't have on it. Now, if I want to go over to my conflict monitor, see that picture okay, Wayne? Bill's in that? Okay. So I took some snapshots with my phone. So here's what the conflict monitor would look like, or the MMU in this case. So you'll see on the top, it has the conflict. I took this picture last night. So I'm at 4:27, which is 4:30 in the afternoon. So don't get too caught up in the time. It's yesterday's time. But you'll see where it says, so it's telling me it's a conflict, and you'll see where it says channel status. So you'll see where it identifies the arrows. I have arrows on 2, 3, and 7. If I look down, you'll see that on 3, 4, 6, 7, 8, I either have a red or a green. So I have one indication. I only have one indication. If I look down at 9 through 16, those are all red. Those are fine. If I look at channel 2, I have a red and a green. So we identify right there, similar to what the log was. You'll notice that this log, channel 2 in the controller, where I have a 1 on the red and a 1 on the green, mimics the same thing of what the conflict monitor is telling us. So it's a way to kind of match up and say, oh, you know what? It's definitely a 2 green I see in the controller. I see a 2 green in the conflict monitor. So now I'm going to start troubleshooting my 2 green. So the one thing I can do is I can reset the controller. So if I go back to my, you'll see it did the stop time. Because I just created the problem here, the controller went back into operation. If you had a problem in the field, it may restart, it may not restart. It could kick on, and if we initialize, so we initialize in 2 and 6, it'll come up and run, and then potentially it'll fail again once we start getting to another conflicting stage of 3 and 7. So once we got here, If that 2 green was on constantly, we would kick out again. So basically, that would cover how a conflict would work. So the problem could be a field short, it could be a load switch. So the quickest thing to do is, I always say, take a load switch out. So in this case, it would have been load switch number 2. Let me go back to the screen so you can see where I'm going. So in this instance, our problem is in load switch 2 green. So simply what I typically would tell people, if you have a spare load switch, take the load switch out, put the other load switch in, see if it fixes your problem. If you don't have a spare load switch, take this load switch and swap it with one of its neighbors. See if we can move the problem. If we move the problem from 2 green to 4 green, then we know the problem is in the load switch and the load switch is bad. If we swap load switches and the problem stays in 2 green, then we know the problem is out in the field somewhere. So now it has to be addressed in the field. And the one last way to confirm that, and I didn't bring one with me, is I always ask the last thing that a contractor should carry with them are dummy lamps. So basically a receptacle that has a lamp in it, an incandescent lamp. And what we can do is take that lamp and we can tie that lamp load onto 2 green and then over to the ground bar. So that is going to, we can take the field wire off. So take 2 green off, put the dummy lamp on, run the intersection. If it runs all the way through 2, now we've definitely confirmed that the problem goes back out into the field, whether it's a nicked wire, a short in the head, something of that nature. But that's where those dummy lamps come in handy. Now, I will also say dummy lamps are a temporary troubleshooting. So many times we all open cabinets and we see dummy lamps in there, we see LEDs in there. So what was put in as a temporary fix becomes a permanent fix. I understand, we don't have a lot of time, we don't have a lot of resources. It's always in our best indication. It's always in our best interest to try to repair those lamp load issues the proper way. If you're gonna pull a cable, change the lamp out, whatever it is, so we don't have them running in the cabinets. I'll just leave it at that. I understand there's a lot of them out there. I'll just leave it at that. Okay, so that covers conflict flash. All right. Now, this is one of the harder ones that people have. So I'll go back to the controller. Well, I'll show you how I do it. So the next one we're going to do is red fail. So people get very confused with red fail because they automatically think of it as the red. It better should be called signal fail because it can apply to red, yellow, green, walk, don't walk. Basically, a red fail, more times than not, is associated on the 24-volt input side. So that would go back to a controller. That would go back to a cabinet issue. There are instances where I've seen red fails happen on the field side, but more times than not, we had a failure in that 24 volts DC on the input side that didn't allow the signal to light, that didn't allow the load switch to change over to the 120 volts to light the lamp. So when we have red fails, we kind of go back to the cabinet. Think of it more as a cabinet problem than a field problem. So one way I'm just going to create is I'm just going to pull out a load switch. Okay, so I pulled it out. Let's see what happened. So you notice right now, just looking at it, so all my load switches are on. I have the input side on, no output, and my signals are in flash. So we'll go over to the controller. So I'll go FFF back to the main menu. So I got Joey on the line. So I'm like, Joey, what's the controller? Go to the lower right-hand side. He tells me we're in stop time, ring 1 and ring 2. I'm like, okay. So I'll say, okay, go FFF to the main menu. Then I'll say go 0 for reports and 4 for alarms. Again, it's not registering anything. So I'm like, okay, so it's not a controller generated problem. Let's go see what the MMU side is. So I'll say to hit the F key, So now let's go to 8 for MMU. Now, right now, it's telling me conflict fault. That was the previous fault. When we want to go to the most recent fault, I'll tell you to hit the up arrow. Now we've gone to the failure that we're looking for. So you'll notice that it says red fail. So if I look at the indications, the way we went through it on conflict flash, you'll notice I have ones under everything, but 1, 5, and 8. So we know that we don't have a red under 1 and 5 because that's a green arrow only. So those ones okay. So the only other one that's missing is 8 red. So I'm gonna already start going in that channel 8 red could be a problem. So now I'm gonna say, okay, let's go over to our conflict monitor. And so now we open up the conflict monitor, and here's what the screen is going to tell you. So it's going to tell me I got a red fail. Again, we're looking for where that down arrow is. If I go over to channel 8, I'll see that I have my red arrow down there. So again, the red arrow in the conflict monitor mimics the missing red on channel 8. So you see, again, we're doing the checks and balances. I see it in the controller device. I see it in the MMU device. So we're basically going to say, okay, my red arrow, I lost the signal. So we know it's supposed to be in red. So we're going to say, okay, our red indication on channel 8 is bad. Let's start troubleshooting that. So in this case, let me go back to the control screen. You guys can see what I'm doing here. All right, so all I do is plug the load switch back in, okay? Come over, I hit the reset on the monitor. Let's get our monitor up here, our controller up here. And it went through its little lockout, and boom, we came back on. So in this place, we just happen to have a faulty load switch, basically on the input side. So the 24 volts was not lighting on the input side, which we couldn't turn on the load switch, and that was giving us our red fail indication, or no signal indication is a better terminology for that. So for this instance, again, we replaced the load switch. Red signal comes in a lot of different forms. Just think of it in the way that I basically probably have a 24 volt DC issue. So let me troubleshoot that from that standpoint and work at it from that one. So I did another red fail. Let me do that one. So we'll go FFF to here. So this one is, again, so all our inputs and outputs in the TS2 controller run through our BIUs and our BIU cables. So when these things go bad, so in this instance, let me just show you on the camera, sorry about that. All I did was I unplugged the upper BIU. So I just pulled it out of its chassis over there. So instantly, go back to my controller. Now I have a cabinet diagnostic flash. So I go FFF111, go to the lower right hand. It says cab diag FLSH. You gotta learn what these acronyms mean. That means cabinet diagnostic flash. Okay, so when you see the word diagnostic, think that you now have a communication problem between some of the devices, between the controller, the MMU, the BIUs. Something's not communicating inputs, outputs, and correct voltages, which is causing the intersection not to run. So I'll say, okay, we have cabinet diagnostic flash. Now I'm like, we're probably going to see something in the report log. So we go 0 for reports. And we go 4 for controller. Boom. So I got, again, my proper month and date, and I got my hour and minute. It's 11 o'clock. It's 11 o'clock now, and you'll see frame 138 fault. So I know a frame 138 fault associates to BIU number 1. I can send you in the back of the Siemens controller manual where it says commands and responses. it lists all the frame numbers and the faults and what they go to. So frame 138 would say TNF, Terminal Facilities 1, which is TNF, Terminal Facilities is our back panel, and then BIU is number 1. So I know 138 is, the upper BIU is my problem. That's what I'm going to look to. If I go look at my MMU, my MMU is going to come up and it's going to tell me red failure with the timestamp. And then if you notice, channels 1 through 8 all have arrows above them, against, but not 1 and 5 because it goes to the flashing yellow arrow. But I have indications under 9 and 16. The reason why is the upper BIU, jumping around a lot, try to bear with me. My upper BIU, or TNF number 1, covers my first 8 load switch channels. 1, 2, 3, 4, 5, 6, 7, 8. My lower BIU does my bottom 8 load switch channels. So because I unplugged that BIU, I've lost all communication to channels 1 through 8. So it doesn't know how to report anything, so it's reporting the whole thing as a signal fail because it can't see anything down there. If we had this is a 16 position back panel. This is a 16 position back panel, as you see, a little bigger than what you're used to seeing. We've traditionally always had 12 position back panels. If it was a 12 position back panel, the upper BIU number 1 would still do 1 through 8. BIU number 2 would only do 9, 10, 11, and 12 because that's the only ones that I have. So that's associated with that. So again, I go back, so I lose out 1 through 8 because of that. So now, let's go back to my controller. Actually, so now I'm going to take this, and if you can see right here, I know you can't see it because you can kind of see above my cable right here. You'll see the lower one right here. You can see the transmit lights. Receiving, it says TX and RX, and then there's a green power light. You can just barely see it. But you'll notice I got the same BIU up here. It's totally dark. Obviously, I'm unplugged to have no power, but if it was plugged in and it was dead, this is what it would look like. So what I'm going to do is I'm going to pop that back in. You can hear it click. And as soon as I click and pop it back in, you'll see now in this blur that I now have my same transmit and receive lights coming on. Go back to my controller. Go, I hit my reset. And we're going to clear the fault. Now we're back up and we're running signals. So that's the same problem, a red fail, generated 2 different ways. And there's probably 50 ways to generate a red fail. I just wanted to give you an example of 2 just to kind of show you how it generates the fault and how it kind of points you in a direction. One thing that it'll show you also, okay, so the solution would be to swap out the BIU and then restart the cabinet. If that doesn't work, try swapping the SDLC cable. Let me go to my video. So if you got another BIU and plugged it in and it took off and ran, great, you're done. It's working. If you put another BIU in and it doesn't run, then I would try swapping the cable from here to here, or maybe the cable up here, because maybe the problem is in our cable. Just if we know that it's a brand new BIU. Or a lot of times, I know this BIU is good, so I'll put this one up here and I'll flip-flop them like that to try to see where it's going. So you kind of keep track, and this is what I'll walk you through over the phone. I like to kind of use the equipment in the cabinet that I know is good and just move it around to see if I can move the problem or if the problem stays put. So that would be a BIU failure. I know we've all seen a lot of them. That'll generate a red fail. Just to kind of go back to TS1, the red fail in the red fail in the TS1 cabinet because I don't have all the BIUs, would be a wiring. So it'd be a wire that's coming off of one of the A, B, and C cables, is not making contact down, it's soldered on the back of a load switch or on a back panel, that's not making a good connection. So that's kind of how I would generate one in a TS1 cabinet. Okay, so that covers red fails. All right, now here's another one that comes in all shapes and sizes. I did 2 examples of it. Is a port 1 fail. So port 1, we refer to port 1, all the SDLC cables the port that they plug into is referred to port 1. So I have a port 1 on my controller, I have a port 1 on my MMU. Okay, so when I have a port 1 fail, it generally means that I have an issue with the port 1, or I've lost communication to that port, so I'm going to generate a port 1 fail. So the easiest thing for me to do right now is I'll create a port failure by just unplugging the MMU cable, the SDLC cable for the MMU. Okay, so I'll go to my controller. If you look down, you'll notice my load switches are all flashing right now. Remember when we did conflict and red fail, they were staying on the input side. Now they're completely flashing. So again, these are questions that we're going to ask. What are your load switches doing? That helps us kind of pinpoint. You might be wondering why 9, 10, 11, and 12 aren't flashing. Those are my PED signals. So I have 8 vehicle signals, I have 4 PED signals, and I have 4 overlaps. So my PED signals don't flash when I'm in emergency flash. They go completely dark because we want pedestrians to know it's not safe to cross using the signal identifiers. You have to cross on your own. Be careful, the intersection is in flash. All right, go back to my main menu. I look down, cabinet diagnostic flash again. I'm like, okay, this is going to be something in the cabinet, so I should be able to get something out of the log. So I go to reports, I go to 4 for alarms, and I hit that up arrow. Okay, so you'll see at 11 o'clock and 11:05, you'll see 11 o'clock I had 138 fault, and 11:05 I had 138 online. That was my fault I had with this, my upper BIU, and then when I plugged it in, it came back online. So now I have 3 new faults at 11:08, frame 128, 129, and 131. If we refer back to the manual, we know that 128, 129, 131 those are MMU faults. So when I see those, I automatically know something's going on with the MMU. Either the MMU is bad or the MMU, I got a port 1 or a cable problem. If I go to F and now I go to MMU CMU and I go up arrow, I have my conflict, my red failure, but I don't have anything else. I just have those 3 faults. And if I look at my timestamp, right, I know if I go F and 4, my MMU frame fault over here is 11:08. If I go F and into my MMU, if I look in the top right corner, I don't have an 11:08 because the MMU, the port 1 cable came off. So now the MMU can't register the fault because it doesn't have the communication. So it can't register a fault. So that's why we don't have one there. So now if I go to my MMU, close that. So if I look at my MMU now, it basically just tells me I got a port 1 fail. The other telltale sign is, I should have took a picture of it, but it tells me port 1 fail. Basically it tells me where it was when it went to a port 1 fail. So last night when I did this, I was in 1 and 5 green. But if I go to my camera, you'll notice with the cable off, it's hard to see, but I would have my transmit and receive lights flashing. They're completely dark. So if my cable was plugged in and those were dark, I would basically say, you know what, probably my MMU is bad and I got to change out my MMU. Or it's the MMU or it's the cable. So I would have to change out one of those other things. So what I'm gonna do is I'm just gonna put this guy back on. Okay. So as soon as I plugged it on, I know it's kind of blurry, but you can see the flash going back on. So that means I'm reestablishing communication. And you'll see that my signals came back on. So now we're up and running again. So that was an example of a port 1 fail on the MMU. Another thing about the MMU, as you guys are doing this, I think I covered this. Hold on, I want to try to stay in line. Okay, let me get through port 1 fail, and then I'll get on to that. So basically, a port 1 fail with the MMU, it's either going to be the cable or it's going to be the MMU itself. So that's pretty straightforward. Again, it's key to have spare parts to do this. Otherwise, you know, the downside, you're kind of dead in the water if you don't have an MMU to get this back up and going again. One thing I just wanted, while we're talking about MMUs, is we have TS2, you have standard MMUs. Sit back down because it's weird. Maybe it makes no sense. So you have this one. You'll see this guy right here. Okay, that's an MMU2 or an MMU smart monitor, and it tells you right on top of it. Right, this is nice. We get the liquid crystal displays. One thing to keep in mind when we're using an MMU2, which basically came out when we had it, when we started using flashing yellow arrows, because that's when, look in the cabinet over here. So my flashing yellow arrow, so load switches 1 and 5 just have a green on it, and they're associated to 13 and 15, which are the other side, the other 3 indications on that 4 indication signal. So I got the green, on 1, and then I got the yellow arrow, and red arrow on, in this case, 13. Okay, so I have to do some programming in the monitor to kind of create that combination of 2 load switches doing 1 signal. One thing you have to be leery of is, I'll show you over here, is in an MMU2, you'll notice this little transistor, this little black guy right here. All right, if you don't have that on there and you plug in, so the old cards didn't have this. If you plug an old card into a new MMU2, you won't be able to get that functionality out of it. It'll work for non-flashing yellow arrow, but if you want to get the flashing yellow arrow stuff, you got to have that little transistor on there. So just keep in mind that they're interchangeable to a point. I don't have an older one, an older card. I don't. But basically, it looks exactly the same. It just doesn't have the little transistor on it. Keep that while I'm talking about MMUs right now. Okay. So now we'll do the other port 1 fail. So what I'm going to do this time, is that chair in the way? Bear with me. So what I'm going to do now is I'm running, I'm going to unplug the SDLC on the controller. Okay, all I did was unplug that. So now we'll go to our controller, go FFF. You'll see, again, we're in cabinet diagnostic flash. So I'm like, okay, I'm having trouble here. So let me go 0, let me go 4. Right, our previous fails were 1105, 1108. If I hit the up arrow, all right, now I have frame fault 138, 139, 131. So 138 is a repeat offender. So we know that's BIU number 2. 139, just because I know, is the lower BIU. And then we also have a frame fault 131, which again, repeat offender. We know that that's the MMU. What should trigger in your head is like, wow, I got 3 different devices, 2 BIUs and an MMU that have registered frame faults. The frame fault is registered because a command is sent out asking for something and the request has failed to come back in. So it registers a frame fault because we didn't respond properly. So it'll try it 3 times and then it'll register the frame fault. So because I have 3 different devices in there, I'm like, what's common to those 3 devices? The SDLC bus. So I'm like, are all 3 of those devices bad? Maybe it's my controller's bad because they all have to talk to my controller. So now I'm going to look, maybe my controller's bad. So if I go hit the F key and then hit the 8 key, well, let me go back, F4. So it's always good to follow the timestamp. So my timestamp is 11:16. So now I go F and I go 8. I'm looking for a 11:16. I got 11:12, which is the port 1 timeout. Okay. And basically it's just kind of registering where we were. So we were clearing 3 and 5, 13. Channels 13 and 15 in yellow, which are my flashing yellow arrows, they were clearing out. That's why those were the only ones that were on. Okay, so now we'll go to our MMU. So again, we look at our MMU. Our MMU is going to come up. It's going to tell me that we have a port 1 fail. And basically we're going to put it at all red because it doesn't know where it was because we unplugged it so it couldn't decipher where the signals were at the time. So the one thing on here that confuses people a little bit, let me go back to the video, is you have an Ethernet port and then above it there's a red lens that says iRed, and that blinks on and off. So there's no transmit and receive lights on the front of the controller. Some of the older controllers did have the little LEDs on like the 41s and everything. They do run concurrently with the port when it's going, but it doesn't blink as fast as the MMUs do and the BIUs do. This port right here basically is a heartbeat pulse of the processor board. It doesn't have anything to do technically with these ports and how they work. It's basically just telling us that the processor board is working. So always disregard that one. It's just basically when the controller is powered up, that's on. It doesn't mean anything more than that. So try not to confuse that in with where our port, our transmit and receive lights. So unfortunately in this scenario, you basically have a bad control. So you got 2 options here. You replace the easiest thing to do, the quickest thing is we can swap BIU cables. Maybe we have a bad cable that's doing it, or we have to swap out the controller. That's probably the most painful one for everybody. Because A, you don't have a spare controller, and B, even if you have a spare controller, you then got a program. So it kind of creates, so that's a dual-edged sword. So we plug that back in, and the controller powers back up, and we're good to go. So that was an example of a port 1 fail on an MMU and a port 1 fail on a controller. Okay, they do happen. It's just part of what's going on out there. We have a lot of electronic components going on in the TS2 environment. This is what we talk about. This is why we talk about grounding being so important. The better grounding, the more suppression that we have in these cabinets, we can better protect these electronic devices. And even that's not completely, fail safe, because a surge is a surge is a surge. Once it gets in there, it gets in there. This SDLC bus basically has, I think, 18 volts on it. So anything over 18 volts, a lot of times we were seeing before we went to do a lot of different suppression is during hurricane season. Once we start getting into late summer and early fall, the hurricanes come through, the high winds, a lot of the lightning, it would get onto the cabinet and basically get onto this bus. And that's when you would see each BIU get blown out, maybe a controller, maybe an MMU. It became a $5,000 repair or $6,000 repair to replace all those components. So through suppression and better grounding practices, we've tried to eliminate that. The influx of using video detection has eliminated that because we took all the loops and loop buildings out of the ground. So that's diminished it quite a bit, but there's still a lot out there. And then when we shift over to ATC cabinets, you know, in the next 5 years or whatever that's going to take place, there's even more electronics in the cabinet. So, you know, it's something that we just have to kind of do the best to deal with, and just try to protect our equipment the best we can, basically. Okay. Let me sit down and talk about something else real quick. Now, there's one thing that comes up a lot, and you'll see it in a lot of these failures, is CVM. So a lot of times people call me up, Gary, my monitor says CVM fail. CVM stands for controller voltage monitor, okay? So what that is basically just talking about the voltages that are in the controller that are up and running. So if you have a CVM fail, it basically just means that you don't have the proper voltages running in the controller, so the controller can't fire up, so then the cabinet can't run. So CVM basically gets tied to a lot of other failures. And all the MMU is telling you is that I don't have the voltages up and running, so I have to register a CVM fail. So the CVM fail covers a broad scope of things, but typically that's not what the failure is. It's just a failure that's been created due to some other kind of fail, red fail, port 1 fail, basically something that's not allowing the controller to power up. We're going to get a CVM fail. So a lot of people will say, hey, I'm in CVM watchdog. Like, yep, you're in CVM watchdog because we're not running. As soon as we get the thing up and running, we'll clear the CVM. So that's what clearing the CVM means. We're correcting the fault, which is elsewhere, which is clearing the CVM fail, which is allowing the controller to initialize and get the controller to come back up and running. So that's kind of this. So don't get caught up too much in CVM, because you can have a voltage issue, but again, it's generally cleared by something else. The CVM is just what gets registered in the MMU. So you're going to see it a lot. So people get confused. I had this kind of fail, go to CVM. Had this kind of fail, go to CVM. Like, why does it always say CVM? Because that's what it's supposed to say. That's what it's telling us that is going on in the cabinet. We know that it's not powering up. We got a CVM fail. Okay, so that's the little CVM thing. Don't get caught up in it. You can definitely tell me it's going on, or whoever you're talking to on the phone, but we're moving on. We'll always move on in another direction to a more specific failure that's generating the CVM, if that makes sense. Okay. Okay, we're doing good here. Okay, so I got through my CVM. All right. Now we get some more. Now we get a couple of. These are some of the easier ones that we're going to go through. So let me make sure we're on the phone. So one fault that comes up, and this was basically pretty straightforward, is you'll get a 24-volt failure. So this is critical. This one definitely carries over to TS1 land. I'm going to do this. Sitting down, see me? There we go. Oh. Okay. In TS1 and TS1 land, TS1 cabinets, our 24 volts DC is generated out of the controller. Okay. So if you have a 24 volt failure, that means the controller died, you blew the 24 volts in the controller, we got to change the controller out. When we went to TS2, we went to an auxiliary power supply. So at that point, you'll see on my power supply, I have 4 different fuses with 4 different voltages. I got my AC, my 5 amp, I got my 24 volt DC, my 12 volt DC, and my 12 volt AC. Okay. So because we had so much more electronics going on, we had to go to a more robust auxiliary power supply. We used to have 102s, CPS 102s, now we have CPS 105s, hence 2 amp to a 5 amp. So if I want to create if I get a 24 volt problem, it generally means I've lost my 24 volts in my power supply. So the easiest way to do this is I just unplugged the fuse. Okay, so I did a couple of slides in here to try to show you how to demonstrate this. So if I go back over, I go FFF. So here's a little different one. You'll notice I got cabinet, diagnostic, flash, no exit. Okay. So I'll go 0, I go 4, I go up arrow. So I get we got 1127, so it generated a 139 fault. So basically it generated the 139 fault because the BIUs run off a logic round and 24 volts DC. So basically when I took that out, the first thing it saw was the BIU 139, so it registered the 139 fault. So you're gonna say, okay, I got a 139 fault, but this is why I have you look at multiple things, because instead of just changing out that BIU, we're gonna confirm it with other things that we see. So if I go F, then I go 8, remember it was 1127. So now I go to 1127, and instead of seeing ones on red, yellow, and green, like I have a red fail or something like that, I'm seeing plus 24 volt monitor 1. That right there immediately should say I got a 24 volt DC problem, because that didn't register with the red fail, the config flash, or the port 1 fail. It's its own specific failure. So as soon as I see that, then I should automatically think power supply. I should go right to the power supply, and I should look at it and I say, oh wow, my fuse is out. I mean, my LED is out. That means I don't have any 24 volts in the cabinet. Oh, let me go to dun, 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 dun. Plus, I go over to my MMU, sorry about that, and you'll see where it has the CVM, because I lost the voltage, 24 volt 1, 24 volt 2. Again, we're just confirming back between that and that, 24 volt DC problem, okay? I go back to my camera, I go back to my power supply, I change the fuse out, I stick it back in. You can see that my green LED came back on. And because I lost power to there, I probably am not going to be able to get a restart out of this. So here's another thing. So I changed out the fuse, my LED came back on, and I hit reset in the monitor, okay? Nothing changed. The previous failures, I was able to get my controller restart. I hit it again, it's still not coming on. Now you're starting to freak out. Gary, I fixed the problem, it's not coming on, what's going on? So when we go to CVM, what we do is we essentially have latched the MMU. And what that means is you get three resets before we latch the MMU. And when we say we latched it, we basically locked it up. So the only way to clear the lock is we get to cycle power to everything. So I can cycle power it. Sometimes you can get away with a cycle power to the controller. Otherwise, a lot of times I'll say just cycle power the whole cabinet. So I cycle powered the controller. I lost my connection over here, so bear with me for 1 second. My controller just came back up and ran. Close this for a minute. Close that. Hold on. Go back to open that up. Open. And okay, open to see. Okay. All right. You'll see I got my controller back up. it took off and ran. So a 24 volt fail is gonna come right out of my power supply. So there's really no lot of other options on that. Now, let me take that back. So we can have a CVM that's directed towards 24 volts, but let me go to here. So on our back panel, screwdriver here, we have 24 volts on the back panel over here. We have 24 volts on the side panel over here. I can easily lose my 24 volts there, my 24 volts there, or I can lose my logic ground at either one of those places. And we're gonna have a 24 volt problem, but we're not gonna register it as a 24 volt failure, even though we lost our 24 volts. This is where it kind of gets a little more involved. So, because technically we still have 24 volts in the cabinet, now we've lost it from the back panel to the side panel. So we either have a wire that's broken, or we have a, some folks have been lucky enough to be involved in changing out the L board on the back panel. So on the back panel, I have an L board, it's green, that goes down. We've burned out the runs on the circuit board, which were for 24 volts or logic ground, and basically we had to replace that. So I can have a 24 volt problem without a 24 volt failure. If I get a 24 volt failure, it's going to be in my power supply. Okay, so that kind of goes with the 24 volt stuff. All right. Okay, here's one while I'm talking about power supplies. This one throws people for a loop a little bit too. So on your power supply, right, I got my 12 volts DC, another and 12 volts AC, two auxiliary powers. We don't really use them that much. 24 volt DC, the main thing that we'll use it on is sometimes with some network gear that can run 12 volts to 35 volts, but most commonly we'll use it with GPS. So GPS is when we put the little hockey pucks on top of the cabinet, and we tie them into the controller, and they keep time sync with the GPS satellite. We use it for coordination purposes. Remember, we're trying to keep that time sync reference so our offset stays accurate. The other voltage in there is 12 volts AC. 12 volts AC has one purpose in the TS2 cabinet. That's your PED circuit. When I lose that, or I blow that fuse out, I lose my PED circuit. So people are like, hey, my PED's not working anymore. My input is dead. And they start troubleshooting all sorts of other things. And I'll say, go look at your power supply. And they look at it and they tell me the LED is out. So basically, I'll say, that ties to your PED circuit. It's its only purpose in life. So that either burned out on the controller, or commonly you just blew the fuse because you had a short in a button or out in the field, and that blew the fuse. So I got a couple of slides that I can walk you through that'll make this a little easier to understand. So if I go to my pictures, okay. So here's an up close of the power supply. So you'll see it says 12 volts AC, 1/4 amp fuse, and I got the little LED to the right of it. Okay. I'll close that. So here's me with the meter. So I'm on the lower left-hand panel in the cabinet, and I just grabbed. So you got 8 PED detector inputs over there. So I just stuck my meter on ground, and I'm on PED input 4 right there. And you notice I got 12.2 volts AC. While I have that LED lit and I have a good working 12 volt AC circuit, I'm gonna have 12 volts on that PED circuit. The minute I blow that fuse, and you'll see where I just unplugged the fuse holder, you'll see where the LED went out. So at this point in time, my controller, my intersection is still running. I just don't have a 12 volt AC circuit right now. And if I go back to my meter, you'll see that I'm now measuring on that same terminal 2.5 volts. Your PED inputs are not working anymore. Your buttons are not inputting calls. You're wondering what the heck is going on. That's a simple way to check it. Go look the fuse, or take the meter, stick the meter on those right on the PED inputs, the ground bar right below it, and you'll be able to tell I'm on the AC, on the AC part of the meter, and you'll see that 12 volts drop down to 2 volts, 3 volts. Basically not 12, so it's not 12, it's not gonna work. So that's kind of what the PET circuit works for. Again, there's my 12 volts AC. I have my light on it. I measure it, it comes up 12.2 volts AC. I pull my fuse out to remove the circuit, and then I have 2.5 volts. Once I plug it back in, it goes back up to the 12 volts. So that's the 12 volt circuits. I know some people get a little confused on that, but that's how that goes. Okay, 12 volt circuits. I can wait. All right, we got a couple more to go through. Okay, here's one that gets people from time to time. is a yellow clearance fail. Basically, I couldn't really create the yellow clearance fail. Basically, all a yellow clearance fail is, so if you go back to the programming that we did, where we did signal timing, so we have red, yellow, and green timing. In the yellow timing, if any of you tried to change it, that 3.0 seconds, if you tried to make it less, it probably it didn't allow you to change it. So the NEMA requirement is that the MMU or the conflict monitor has to see 2.7 seconds of yellow per phase. If it doesn't see it, then you'll get a yellow clearance fail. And what most commonly happens on that is a bad yellow LED, typically a bad leaky yellow LED. So there's enough load there to satisfy the monitor to keep it going, but there's not enough when it does the transition from green to yellow to red, that it won't see that 2 seconds of yellow time, or that load, that 120 volts, 118 volts on there. So you'll get a yellow clearance fail on that. Other places that we've seen it that have caused that problem is you can have a bad flash transfer relay. Typically they don't go bad. Typically you stick one in there, you get 25, 30 years out of it. But because that ties to your yellow flash circuit, you can have a bad flash transfer relay that can cause that same problem. And there's actually the yellow jumper wire that ties down on your field level wires up to when we do our flash for red, yellow, no flash. I've seen instances where we've had a problem with that yellow wire that has mimicked a yellow clearance flash. But 99 times out of 100, you're gonna have a bad yellow LED out there. We've all played with yellow LEDs. We all know how temperamental they can be. Different manufacturers are more reliable than others. We sell dilated LEDs right now. They seem to be going pretty well. They've been around for a while. It all comes down to when an LED first came out, they cost like $300 each. They had big, huge power supplies in them and hundreds of strings of LEDs. Now they've reduced them down to, if you open up an LED, if it has 10 LEDs in there, that's a lot. And it's got a high efficiency power supply in there, so it doesn't draw any energy. So the town saves a ton of money on the electrical bills. The problem is the components that they use to make these LEDs, they get a bad lot of component A that can take out the whole, that can take out thousands of LEDs. It's a manufacturing thing. All the LEDs are all built over in Japan and China or overseas. So, we're kind of at the mercy of that. In the grand scheme of things, considering the thousands and thousands of LEDs that we use, the failure rate is generally under 5%. So that's not bad, but if you get stuck with a big chunk of that, it's a pain, man. We feel your pain because it's tough. And right now, with everything going on with COVID, the shipping lines for LEDs has kind of pushed all those back. So if you order LEDs and you're waiting on them, that's why. It's the freight. They have them. They're sitting on freight boats outside of California, and they won't let them dock to come get them. It's my little spiel on LED. So that's basically the yellow clearance fail. And then one of the last ones that we can go over is, this is another simple one, causes people a lot of aggravation, is program card ajar. So basically you went and did all your programming, did everything that you were supposed to do. Oh, I don't think I took a picture of this. This is the diagnostic one. If I go to my controller, Cabinet Diagnostic, stop time flash. If I go to 9 and 4, oops, wrong screen, wrong screen. If I go 0, 4, up arrow. It's actually giving me a utilization conflict, which I'm going to go over next. But really, if you were to look on the front of the MMU, I didn't take a picture. It literally just says program card ajar. Basically, you don't have it pushed all the way in. There's these two little white tabs. Right? You have these two little white tabs right here. Basically, you just slip them in, these click down. You'll hear it seed into the connector in the back of the MMU. If you don't hear that, then reseed it again. It can only fit in one way. It can't go in that way. It can only go in this way. The jumper side is to the right. In the old NTS1, you had that other little smaller card that used to be able to pop in and out. It wouldn't give you that failure, but basically you could kind of tell when that thing wasn't in. So we'll put this back in. Feel it pop. Counting down my flash time. So we count down, we're still on the stop time. I hit the reset, and we're gonna pop and come back on. So, like I said, that's kind of an easier one. Again, it just means that the card's not in all the way. Along with the cards is so you sort. Let me get out of this. All right. If I go 0 and 4 and up arrow, the MMU utilization conflict, what that mainly means is that you don't have the proper jumpers in the monitor card. When I say the jumpers, so you'll see in here we have all the little slots with all the channels starting over here 1 through 16, and it goes over 1 to 2, 1 to 3, and across. This is where we put the little jumpers in for our compatibility, based on the ring structure that we do and the phases that we make compatible. And a way to check that is you could have programmed everything perfectly, but if you didn't put the right jumpers in, either too many jumpers or sometimes, or not enough jumpers, or sometimes too many jumpers, you'll get a utilization conflict. And the easiest way to check that is you go FFF to the main menu, you go 4 for unit data, 9 for output mapping, and then you hit where it says D for display compat. It's basically showing you the MMU card. So you can see where it says LS1, and then you go across. So in this case, I have jumpers in 5 and 6, 11, 13, and 15. So wherever there's a 1 on here means that there needs to be that jumper in the associated card. So if that all lines up, then it'll take off and run. If we're missing something, then it's not going to run. So go back and check that. So again, that's going to be at 4 for unit data, 9 for output mapping. And then you'll notice in the middle it says D for display compatibility. And there's our output compatibilities. So make a note of that. That's good information to have. And then the last guy that we have, this one again is pretty straightforward. I have a bad MMU right here. I'm just going to unplug this. Plug this guy in. You never want to see this one. time here. Go back to video. All right. So I have a bad MMU, a known bad, we gotta send it back for repair. I put that in there, and basically here's the error message that it has on. Diagnostic logic 0. If you come out to an intersection, it's in flash, and you look at that, instantaneously, you got a bad MMU, there's something failed inside, something got burned up inside, just replace it. There's nothing you can do for it. Send it back to us. EDI makes the best monitors. It doesn't happen very often. It usually means it was a surge or something like that. I forget how long their warranty, 3 years or something like that. But get that back to us, because basically, again, you're dead in the water. You need another MMU to get this whole thing running. So let me pop this back out. You don't need to really go hunting through any other logs when you see that kind of report. When you see that on the monitor, because it's basically it means one thing, and we know it right there from the MMU. Plug that guy back in, hit the reset, see if we can get up and running again. Here we go. And we're up and running. But, because I killed my, what do you call it? I'm going to reconnect this one more time. All right, here's my front panel running again. And here's my control screen. So, so that basically, sit back down. Oh. So that basically covers a little bit of TS2 troubleshooting. It was a little tricky going back and forth with the screens, but I figured I'd try to put something together. You learned about the programming, you learned how to read the prints, the engineering design plans. So I figured now we go over some troubleshooting so you can kind of pull the whole thing together. So you can program it, so you can read the plans, understand the information that's on there. You can program it into the controller to get it running. And now you can do a little bit of troubleshooting if you have a problem to get it back up and running, either with spare parts or without spare parts, and understand what the problem and how the electronics work inside of the cabinet. This is something that takes years of practice and just doing over and over and over. Generally, you have to do it at night. Generally, you have to do it in bad conditions. We all know things just don't fail during the day. But the more you do it, the better you get at it. I always recommend to people, if you come across a spare traffic controller that you can set up in your shop, it allows you the ability to practice on it. So when you're sitting around, you don't have much going on, the weather's bad, you can kind of create these failures and understand what they mean, how the electricity flows through the cabinet, how it ties into programming that can cause the problem. So a lot of different things that can go on. It takes practice. We're recording these videos so you can go back and watch them again, try to recreate the problems in your shop. So then when you see them in the field, they'll be a little bit familiarized. And that's all we're trying to do with these, is try to familiarize yourselves with the problem. So when you see it, you can be like, well, I don't really understand it, but I remember Gary was talking about this in the video. I remember being familiar with looking at the screens, going to the menu logs. So when we have our interaction over the phone, that's one obstacle we've already dealt with. We've kind of cleared that obstacle today, you can navigate through the controller, go through all the screens, and we can get to the root of the problem, get it fixed, get you out of there, and finish out the day. So that's kind of the troubleshooting stuff. I don't know if anybody has any questions. I'll try to answer a few. We got a couple minutes left. Wayne, was there any questions out there? Oh, what do we got?
No questions.
There's a question right there.
That's not a question.
Gary, last week I programmed an NEPAC 300 for Belmont Ash. We are installing a new TS2 cabinet. Did the BIU automatically get programmed when I did a ring structure? So if you put it in, when you put the controller in, so basically if I understand the question, you took out a 300 and you took out an old Eagle 300 and you put in a new we're installing a new TS2 cabinet. Did the BIU automatically get programmed? So I assume that you're changing controllers. So if the controller came from us and the cabinet, it would have been programmed to have the BIUs to be on. If it didn't, then you have to turn that on in the programming through the 4/7 screen. So that's where you're going to make sure that those BIUs are turned on. We turn them on in the controller. We don't turn them on at the BIU. So that's where you have to go turn those on, if that makes sense. If I didn't answer that properly, give me a call and I can kind of walk through that and better explain that to you. Again, anything that you get coming from Ocean State should all be programmed properly. Anything that you do in the field, again, once you default the controller, it defaults to a TS1, so all that TS2 stuff is turned off and it has to be turned on in that 4/7 screen. The 3 BIUs and the MMU and the controller BIU. All right. I don't see any more questions. You guys all know how to get a hold of me. The good news is it seems like a lot of the states are starting to open up. We had a decent attendance today. I noticed it's been going down a little bit each week because I think you guys are just getting busier and they're allowing you to go out and work on stuff. In turn, that means that I'm going to be getting busier here at Ocean State. So what I think we're going to try to do going forward is I'm going to try to make more of these videos and probably just email them out to the group. If something comes up where I can do the video, I'm happy to do it, kind of like we're doing right now. But I can see how my workload is starting to pick up. So I kind of need my Tuesdays to go back out in the field, and I'll be working with a lot of you out there. So feel free to hit me up with questions, write them down. But you can get a hold of me anytime to try to get a hold, to try to go over stuff. If you can't get a hold of me, you got Mike here, you got Wayne here, you got Joel here. There's other folks that you can talk to. I know I don't always answer right when you call. It's generally because I'm either helping somebody else or in the middle of something. But, there's other folks. If you can't get me on my cell phone, call the office, ask for tech support. We'll always get you somebody to try to get you through your problems. So if there's nothing else, then I appreciate everybody tuning in. I thought it was a good 6 weeks, kind of kept me busy during everything that's going on. And hopefully we can, hopefully this won't happen again. Because I think we all enjoy being outside way more than we enjoy being quarantined. So anyway, everybody be safe, work hard, and just keep learning. You got to learn it yourself. That's the one thing I'll leave you with. You got to take the initiative to learn this yourself. I can only give you the tools. We can all give you the tools to do it here at Ocean State, but you got to want to learn it yourself. It's not easy, but it can be done. And if you got an interest, you can figure it out. All right, guys, have a good week, and we'll talk to you soon. See ya.